Alright, so we've got these problems here where we're looking for a number of unpaired electrons, and what I would be inclined to do is just write out the electron configuration. So we'll do sodium first, and then I'll show you how you can use the electron configuration to get the unpaired electrons. So we go over here, we've got 1s2, and there'll be 2s2, brings us down to here, 2p6, and then 3s1. Now if there's going to be any unpaired electrons, they're going to be in this top energy level, that is the highest energy level, the outermost electrons. So this would end up being 3s, and I put just one electron in, because sorry, one orbital in, because it's an s orbital, and I've got one electron to put in there, so I do that and I end up with just one unpaired electron. Now just in case you don't believe me about the unpaired electrons being in this top energy level, if I was to draw this out, here's what it would look like. Here's how I draw it out. So if I was going to do this, energy goes up this way, so I have to start at the bottom and work my way to the top, and I've got a total of, let's see, we've got 11 electrons. Sodium has an atomic number of 11, so there's 11 protons, which means there's 11 electrons. So I go ahead and put those in. I have to put 2 in here, then 1, 2, and then 3 and 4. Now in the p level, because of Hund's rule, I have to put 1 in each first before filling them, because they're all the same energy. Now whenever you've got orbitals of the same energy, you have to do one at a time first and then fill them at the end. So this would be 1, 2, 3, 4, and now this is 5, this is 6, and this is 7, and that's 8, 9, and 10, and then 11. So you can see that all of these down here are going to be paired because they're all full. And that's always going to be the way it's going to be. You don't even have to do all this. You just have to look at the last one and see if there's any paired electrons in there. Alright, let's take a look at bromine. Bromine's all the way down here, so we'll go ahead and do that. It's 1s2, 2s2, 2p6, 3s2, and we're down to here at magnesium now. Now we're going to go over here. This will be 3p6, and now we're going to go down here. It's 4s2, then 3d10, and then we go over here, and because this is 2p, 3p, 4p, this will be 4p5 to get over to bromine. Now remember, we're only interested in this last one because all of these here are going to end up being paired. So I'll do my 4p orbital here. I've got 5 electrons to put in. So going by Hund's rule, as I discussed before, I'll do 1, then I'll do 2, then I'll do 3, then I'll do 4, and then I'll do 5. And as you can see, we're going to end up with one unpaired electron out of that as well. So one unpaired electron in that one as well. Okay, let's take a look at sulfur. So we go ahead and we do our electron configuration: 1s2, 2s2, 2p6, and then we'll do 3s2, and then we go over here 1, 2, 3, 4, and that'll be 3p4. Again, we're just going to focus in on this last one because that's where the unpaired electrons will be. So it's a 3p, which means we're putting in 3 orbitals, and we've got 4 electrons to put in. So using Hund's rule, we'll do 1, 2, 3, and then 1 down here, that's 4. That leaves us with 2 unpaired electrons.